these 3 cards here. How many ways can I order them? Well, one way to count the options is to go through the actual process of arranging the cards and count the ways to go about each step. Well, the first step is just putting down the first card in the row. I have 3 cards, so there are 3 ways to do this. Now, no matter which card I put down, I only have 2 cards left for the second card, so I only have 2 options for the second card. Now, I only have 1 card left, so that has to go in the final spot. This gives us a total of 3 times 2 times 1 equals 6 options, and we can test this to see that, yep, there are exactly 6 ways to arrange the cards. One confusing part about this is why this is times and not plus. It may or may not help visualize this if I arrange the cards like this. Either way, I would like you to pause the video now and explain this to a friend, or a family member, or a pet, or a pencil, whatever works for you. Great! So mathematicians started to get annoyed when they were talking about the arrangement of, say, 15 cards, and they had to write down 15 times 14 times 13 times 12 times 10, times 11 times 10 times 9 times 8 times 7 times, you get the point. So they made this shorthand for it, which is just an exclamation mark. So this is read as 15 factorial, though I think it would sound a lot cooler if we all just said 15. But in that example, I had picked the 3 cards I wanted to choose already. What if I had narrowed it down to 5 cards? How many ways could I arrange 3 cards when I have 5 cards? Well, the way we would normally do this, I think, is to choose 3 cards out of the 5 and then arrange them. But we have no idea how to choose things yet. So let's try what we do know, which is ordering the 5 cards. So now we have 3 cards in these 3 slots, but we don't care about the order of these last 2 cards. So we can unorder this by dividing by the ways to order the last 2 cards, giving us a total of 5 factorial over 2 factorial, or 5 over 2. There is a simpler way to get to the same answer. Can you find it? Could we do a similar thing to figure out how to choose things without caring about the order at all? Well, we could start the same way, arranging the 5 cards and then unarranging the last 2. But we also don't care about the order of the first 3, so we can unarrange those also. This gives us a total of 5 factorial over 2 factorial times 3 factorial, or 5 over 2 times 3. Does this unarrange the whole thing? Why or why not? So this is what we call choosing things, and the shorthand for writing 5 choose 3 is going to be these long parentheses things, 5 choose 3. And the interesting thing about probability is that choosing things is actually related to a lot of seemingly unrelated concepts. For example, it's connected to somewhat unrelated topic of algebra. What if you had the problem x plus y to the 10th power, and you wanted to expand it? You don't want to expand this all out. It's going to take forever. But instead, I'm going to write it like this. X plus y times 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 x plus y times... You get the point. Then for each term, we choose 1 variable from each factor to multiply for a total of 10 variables. Now, if we want to find the coefficient of the x to the 5th times y to the 5th term, note that there are 10 variables multiplied together. You need 1 from each, which means that the sum of the powers has to equal 10. So each way you can choose 5 x's and 5 y's is going to give you another term. And then the sum of those terms is going to be whatever the coefficient is for your x to the 5th plus y to the 5th term. X to the 5th times y to the 5th term. So we have to find the amount of ways to choose 5 out of the 10 factors to be set to x, and then the rest we can automatically just set to y. Then there are 10 choose 5 ways to choose this, so the coefficient of the term is 10 choose 5. So now we can expand this a lot more quickly than we could before. That's a cool trick. And shout out to those of you who are in top 4th period who saw this already. But that's all for now. See you next time.